This video focuses on origami designs by the Japanese creator Tomoko Fuse. The designs are what Fuse calls whirlpools, and they can be found in her new book, Spiral, published by Vierik Verlag. Here are several varieties of whirlpools that I've folded. Each one starts from what is known as a crease pattern. A crease pattern is a set of lines that serves as a blueprint of sorts for the origami model. For example, the crease pattern for the whirlpool in the upper left looks like this. By printing this design on paper, cutting it out, and folding along the lines, the paper can be collapsed to form this whirlpool. All of Tomoko Fuse's whirlpools share this basic pattern, but vary the number of triangles in each row and column, as well as the angle measures of the triangles. Here are the crease patterns for the other whirlpools on this page. This video shows how Sketchpad can be used to build a whirlpool template that can easily be customized to suit the large collection of whirlpool designs in Fuse's book. Now, let's learn how we can use the Geometer Sketchpad to build a template for Fuse's whirlpool patterns. Here we have a triangle ABC. Angle A is defined as the angle of spirality, which in this case is 30 degrees. Fuse calls angle B angle beta, and will soon use the angle of rotation, which is currently 10 degrees. Now if I select something like the angle of spirality, I can press the plus and minus keys on my keyboard to change its value. This will be useful when we want to vary the template to create different whirlpools. But for now, let's work with triangle ABC. I'll start by taking this triangle and translating it by vector AC. To do so, I'll select point A and then point C and choose Transform, Mark Vector. I'll then select the entire triangle and choose Transform, Translate. And now we have a copy of the triangle sitting end to end. Now I'd like to take this translated triangle and rotate it by 10 degrees about point C. So to do that, I'll double-click point C to mark it as the center of my rotation, and I'll select the angle of rotation and choose Transform, Mark Angle. Now I'll take my triangle, go back to Transform, and choose Rotate, and I will rotate it by 10 degrees about the center point C. Now that I've done this, I no longer need to see the triangle that I translated. So I'll select its vertices and sides and choose Display, Hide Objects. So now we have a new triangle, triangle C, B double prime, C double prime. That's the result of having translated ABC and then rotating it by 10 degrees. We're going to continue this pattern over and over again. We'll start with triangle C, B double prime, C double prime. We'll translate it by this vector, C, C double prime, and then we'll take the result and we'll rotate it by 10 degrees about C double prime. And then we'll continue this pattern again and again. So on the next page, I'll show you the result of having done this. Here we see the result of applying the translate and rotate transformation 4 times. We have 5 congruent triangles, and these triangles form the first curved row of our whirlpool design. Now to make the next row, we're going to start by taking these triangles and translating them up so they sit on top of the existing row. We're going to translate the triangles by vector CB. So I'll mark that vector, and then I'll select my triangles and choose Transform, Translate to create the translated triangles. So here we go. They look good, except the triangles look too big. We really want the vertices of the translated triangles to land squarely on the vertices of our existing triangles. So we're going to need to scale them down a bit so that they fit well. But before I do the scaling, I'm going to create a Hide Show button. With these triangles selected, I'll choose Edit, Action Buttons, Hide Show. And with this button, I can now hide the triangles. And when I press Show Objects, all of the triangles are selected. The nice thing about that is now that when I choose to dilate them, it's an easy step just by pressing that button to make sure all of the triangles are selected. I don't need to select their sides and their vertices one by one. To continue, I'm going to hide these triangles. Now I need to make sure that I have vertex B back again. So there it goes. And I'm going to connect B and B double prime to form this segment. Now the amount of dilation I need in order for the second row of triangles to fit onto the first is defined by the ratio of B, B double prime to C, C double prime. So to form that ratio, I'll select in order the two segments, this one first, then the other, and choose Transform Mark Segment Ratio. There. Now, let's show those triangles, and I'm going to now dilate them. So I'm dilating them with B as my center, and if B wasn't selected, I would simply click on it here to make sure that it was my center, and it's by a scale factor that I indicated before. So I'll press Dilate, and let's create a Hide Show button for these new triangles. Okay, and we can hide the triangles from before. We no longer need to see the triangles that were just translated. So this looks pretty good. My new row of triangles looks like it's sitting right on top of the first row, but let's just check this out. I'll select the angle of spirality, and let's try some larger angles. And that's not looking so good. The triangles are breaking apart. So what can I do now to fix this? Well, by looking at this, I think there's only one step left to take. This row of triangles here needs to be rotated so it gently lands on top of this row. And the amount to rotate it looks to me like it's just this angle here, this very small angle. So let's measure that. First, I'm going to bring back point P, which keeps getting hidden. And I'm going to select these 3 points and choose Measure Angle. And we want to rotate by -5.34. So let's use our calculator to compute that. There we go. So now I'm going to mark that angle and use this Hide Show button to select my triangles that I want to rotate. Choose Transform Rotate and press Rotate. Okay. So I no longer need to see my prior set of triangles, so let's hide those. And now I will connect point A to this point above it. And let's see if what we have here works. Let me try changing the angle of spirality and see if this holds together. And it looks like it is. That's pretty good. So here we have the first 2 rows of our whirlpool, and to continue we no longer need to build this one row at a time. We could select both of these rows and then translate them as we did before, and after translating them we could dilate them by the appropriate amount and then rotate them, and that will give us 4 rows of the whirlpool. With 4 rows available, we can apply the same transformations again and go from 4 to 8, and then go from 8 to 16. I don't think we need to go from 16 to 32, but we have plenty of rows available to us to make the designs in Fuse's book. Here's the result of applying those transformations over and over again. This gives us a template for a whirlpool. Now the actual whirlpools in Fuse's book have differing numbers of curved rows and columns. This pattern in itself is not one of them, so don't try to fold this one. But even without folding it, it's very interesting to try changing the angles and see what effect that has on the picture. Just look at the way this illustration updates itself as I change the angle measures. It's fascinating in itself. But let's say you'd like to actually fold a whirlpool. Well, I provide a sample whirlpool here, and it has these angles, and it looks like this. And in order to print it, you should select these angles and hide them, because they're going to take up some valuable room on the page when you're printing. And then you'll go to File, Print Preview, and choose Fit to Page, and then just print. Continue by cutting out the crease pattern. When you do, you're now ready to fold it. Start by folding all of the lines on your paper. Here you'll see I'm folding back along the first red diagonal to make a nice sharp crease, and here I'm folding the second diagonal again, making sure my crease is accurate. And I'm going to fold back along every single crease on the paper. This allows me to make sure that I'm making the crease exactly where the line is. You don't want any inaccuracies when doing this. Now, origami models come with two types of creases. There are valley folds and mountain folds. What I've made until now are all mountain folds by folding back along the paper. But the black lines are actually valley folds. So to put those into place, I'm changing the direction of those creases here. Valley folds fold toward me. Now that I have the creases in place, I'm ready to assemble the model. I'm going to start by working on the bottom row. I'm making the mountain folds along the red diagonals and putting in the valley folds along the black lines. So the paper switches directions as I fold back and forth. And this bottom row, with a little work, comes together to form an interlocking triangle. That's the base of my whirlpool. Now I'm ready to make the second row, which is done much in the same way, but it's a little easier now because the paper is locked together. And I'm just twisting that row so that the paper comes together and forms another triangle. You can see that triangle if you look inside the model. And I continue that procedure up and up and up. It's the same on every single row, except the rows get smaller as I go along. And here I'm working on the final two rows, putting those into place. Those can be a little tricky. The paper gets smaller row by row, but again, be patient. Make sure you're folding along those crease lines, and you should end up with a nice springy whirlpool when you're done. The very top of the whirlpool has a triangle, much like the bottom of the whirlpool does on the underside. Here I can spring it up and down, and it looks particularly good when I look at it head on. And here, voila, is the whirlpool.